sent you an email with your grade summary, so please take a look at that. Thank you for suggestions. I'm now going to post the Rardin PDF files. Once we finish the chapter on that, I'll post those, and it'll be like, so for quiz 2, we finished chapter 2. Right under that quiz, you'll now see, once that quiz has been submitted, you'll see chapter 2 solution for every problem at the end of chapter 2. You can go through and look at the ones that were assigned. Because quiz 2 had a display error for at least one of you, I gave you all the benefit of the doubt. It was a weird error. I think it was Zach might have gotten. So I gave everyone 100 on that quiz, so Merry Christmas early. However, this was the most common problem that I actually saw on quiz 2. The first question on quiz 2 was chapter 2, number 18. It was just classifying a problem. D of that problem had a log in it. It was like W was the variable and then divided by a log of beta. The beta was a constant. So it said that the WJs were greater than 0. So many of you considered that that was nonlinear. However, because the nonlinearity, the ln was applied to a constant, we're still just dealing with a linear program. So that was the most common error. So check out the solutions for 218. Talk to a classmate. I would say maybe a third of you missed that one. Again, comments from you guys. I went ahead and changed a few settings in the quizzes. So you now have 2 attempts. This is meant to reduce anxiety if you just did a typo. And I'm also going to show you the ones that you got wrong, so then you can go back again. It's meant as a study guide, and then we'll have solutions posted afterwards. Okay, in general, doing a really nice job in the class though. So the group work, I'm going to take a look at your theory this week. So I'll be grading that and putting the post in the spreadsheet next week. But for a few brief things about the theory, I do remember, thank you to folks that post comments right there when they submit theirs. So like Kevin, yes, the printed solutions are now in Oak, so you can go back and look at my theory solution. But it was neat just glancing at your guys' work to see how many different proof techniques there were. Jenna, thank you for also noting that. I think Jenna has never had a proof writing class, so many of you are math majors, and Jenna, your instincts were great. You did a wonderful job. I would suggest talking to someone like May, who did a really nice job on her proofs. One of the things I liked about that is she sort of walked through her thought process throughout, which is very similar to yours, Jenna, but you could see some of the ways of formalizing your thought process to make it a formal proof. So yours was a really nice job. And again, I'll have more comments on each of these as I grade them this week, but those were the overall general comments. I remember in particular Ashley's and Brianna's and Michael's, just very concise and well done. So in general, nice job. And hopefully everyone sees the point of that one. Like if you just add a constant, I think many of you said it doesn't change the feasible region, whether you're linear or nonlinear, but it will change the objective function value. And you're able to answer that. All right, so it's going good. And I think you're gonna have a really good time these next several weeks and even months. So we have a test coming up soon. We're going to finish chapter 3 and have a test on Monday the 27th. So as it gets closer, I'll have more announcements and we'll talk more about that. But you're doing great so far. We're going to be sailing, and then it gets very, very interesting material. All right, have a good one with this week's material. Shoot me an email with questions.